So this lesson, we're going to look at graphing the tangent function. So the tangent function has a different look than sine and cosine, and it's because of stuff like this. So if I did the tangent of 0, I know that on unit circle, the coordinates are 1, 0, and tangent is the ratio of sine over cosine, or y over x, so I get 0 over 1. At pi over 2, the coordinates are 0, 1, and if I do the same thing, I get this, which is undefined, versus 0 over 1, which is 0. Tangent of pi is 0, but the tangent 3 pi over 2 is undefined. And as we've learned previously, every time we have something that is undefined, in other words, we divide by 0, it creates a vertical asymptote. So what we have is, every time we get to 3 pi over 2 or pi over 2, we end up with an undefined function or a vertical asymptote. Another thing that's a little bit different is the period of the function. So from 0 back to 0, it was exactly pi. So the period of the tangent function is pi. And guess what? It doesn't have an amplitude. Not applicable. And that's because, we'll see when we graph it. So because the period is pi, we're going to use some different points for our function than we normally were using for sine and cosine. Okay, so we're going to go ahead and we're going to put 0 in the middle, and then we're going to go by fours. Pi over 4, pi over 2, and then negative pi over 4, and negative pi over 2. So these angles are in quadrant 4, and these angles are in quadrant 1. In quadrant 1, tangent is positive, but in quadrant 4, tangent is negative. So if I go ahead and we already said pi over 2 is undefined, therefore we don't really need the negative. And we know negative pi over 2 is just going to be the opposite, but again, there's no such thing as positive and negative undefined. Pi over 4 on the unit circle, remember, is square root of 2 over 2, square root of 2 over 2. And if I do y over x, I get positive 1. But in quadrant 4, it would be negative. And we know that the tangent of 0 is just 0. Okay, so first, when we go ahead and we do our graph, we're going to do our asymptotes, which are at pi over 2 and negative pi over 2. It's crossing the x-axis at 0. And I know that there's a point pi over 4, 1, and negative pi over 4, negative 1. If I went ahead and I did some more points, like pi over 8, I would see that my points are just going to get, my values are going to get bigger and bigger and bigger as we get closer and closer to pi over 2. So there we have our parent function for a tangent of pi over x. And because of the periodicity of pi, I know that if I go one more pi, so I'm at 3 pi over 2, I'm going to get a repeat of that function. And if I go in the negative direction, pi units, to negative 3 pi over 2, again, I'm going to get just a repeat of that function. And so there we have our tangent function. Okay, so with transformations, we know that this number is going to affect the vertical stretch and reciprocate if it's negative. We know that this number moves things left and right horizontally. This number changes the period. So in this case, the period of the tangent function is pi over b. Okay, although we talk about not having really an amplitude because it goes into positive infinity and negative infinity as we get close to the asymptote, this does go ahead and stretch that distance from the 0 and the 1 at y value. So we'll talk about that in a minute. And then remember, k moves it up and, or left and right, up and down. And so remember, k is going to kind of affect what we call, remember, the midline. So in the parent function, the midline is going to be right there on the x-axis, but it's going to move with k. Okay, so looking at this function, I'm going to go ahead and think about that. This is just saying I have the opposite value of a. So a, instead of being positive 1, is negative 1, which means I'm going to have a reflection. So I'm going to reflect it. K is 0, so it's not going to move up or down. And then the 1/2, remember, is the b value. So if I do pi divided by 1/2, I get my period. And so pi divided by 1/2 is the same as multiplying by the reciprocal, which gives me 2 pi. And because there's no shifts left or right, what that tells me is that my asymptotes are going to be right here at negative pi and pi. So if I go ahead and I put in a 0, 1/2 times 0 is 0. The opposite of the tangent of 0 is still going to give me exactly 0. Okay, and then that point that was at pi over 4 is now being stretched twice as far, but it's also being reflected down. And that point that was at negative pi over 4 is no longer going to be at pi over 4, but is now going to be at pi over 2. And it's also going to be reflected on the opposite way. So instead of being at negative 1, it's now going to be at positive 1. Okay, and how we can tell we did it correctly is if we go ahead and we do an input of negative pi over 2, I would do the opposite of the tangent of 1/2 times pi over 2, which would be the opposite of the tangent of pi over 4. Pi over 4 has a tangent of 1, and the opposite of that would be negative 1. So that's correct. So let's look at this one. So on this one, I see my period changed. So the period, remember, is pi divided by b, or pi over 2. My graph is going to be shifted left, pi over 4. Okay, and vertical shift is going to be down 3. And my amplitude, we're just going to go ahead and say it's 1. That's my vertical stretch. So now I'm going to go ahead and I'm going to start off with my parent function. So I know my parent function, asymptotes at pi over 2 and negative pi over 2, 0, 0, 1, 1, negative 1, negative 1. So we do vertical changes first. So my vertical change is just moving the midline down 3. So my midline was here at y equals 0, and now it's moved down 3 to y equals no. Okay, next I'm going to go ahead and change my period. So when I go ahead and I change my period, oops, sorry, I forgot something. So when I move everything else down 3 units, I get my vertical asymptotes still in the same spot, but my graph looks like this now. So now I'm going to go ahead and I'm going to do my period change. So my period is now going to be, instead of 4 boxes long, pi, it's now going to be half of that. So it's going to be changing this way. So everything's getting half as close as it was. So 0, 0 is going to stay there. But this point that was at pi over 4 is now going to be at pi over 8. And this one is going to shift over half a unit. So now that point that was on the y-axis is going to stay exactly there on that midline. But then the point that was one above it and to the right is now going to move half as close. And the one that was one below and to the left is now going to move half as close. So now it's a little more narrow. And now what's left to do is to shift it. I'm going to clean this up a little bit. So now what's left to do is to go ahead and do that phase shift. So I'm going to shift everything to the left pi over 4. So remember, on the coordinate plane, whenever we go 4 boxes, that's a length of pi. Is the way we have it divided up. So that means pi over 4 is just going to be the width of 1 box. So now I'm going to go left. So I'm going to move everything to the left. So that means all the asymptotes are going to move to the left 1 box. And each of my points are going to move to the left 1 unit, or 1 box. Okay, and now let's double check. So my double check is going to be, I'm going to put in this point right here, which is negative pi over 4. So if I go tangent 2 times negative pi over 4 plus pi over 4 minus 3, I expect I should get an output of negative pi over 4, giving me negative 3. So negative pi over 4 plus pi over 4 is 0. And 2 times 0 is 0. And we know the tangent of 0 is 0. And 0 take away 3 is negative